Hi guys, alright, so this is Unit 5, Day 6 notes. We have these 4 learning targets today. Some of them we have been using already. The bearing one, where I can find the area, is going to be a new one. This third one, where I can find the area using Huron's formula. And then we're going to have some application ones that are including bearing. So on the top, let's just write out our law of sines and our law of cosines. We can reference always back to this page of our notes. So sine of A over side A is equal to sine of B over side B, and then sine of C over side C. Then we have our law of cosines. So let's start off with A squared equals B squared plus C squared minus those two sides, so 2 times B times C times the cosine of A. Then that takes us into the B squared, so then A squared plus C squared minus 2 times A times C, cosine of B. C squared is now what? A squared plus B squared minus 2 times A times B, cosine of C. Awesome. So we got to figure out how are we going to use this knowledge to find the area of a triangle. And these are non-right triangles. So area of a triangle we know is 1/2 times base times height, right? But the thing is, do I actually have a height in this one? Remember, height is always perfectly vertical. So it's not in it actually, right? So if I wanted to, I have to figure out how do I use the formulas for this one and where do they come from? So there are a few formulas that we have to know. And let's just say if we wanted to find the height of this, where does it come from? So if I just put a theta in angle A, okay? So like this is side A, this is side B, and this is side C. And I wanted to know the height of this triangle. I could do sine of angle A is equal to opposite over its hypotenuse, which is side C. And if I cross multiplied here, I'm going to get that the height is equal to side C times sine of A. And what I'm actually going to be doing now is substituting what this H represents into our traditional 1/2 base times height. Okay? So the formulas that we need to know is if I have area of a non-right triangle, but it's an SAS triangle, right? I could use either one of these three. So A equals 1/2 B times C times sine of A. Area equals 1/2 A times C times sine of B, or I could use 1/2 A times B times sine of C. Okay? After that, what happens if I have like a different type of triangle? I don't have any angles known. You can use the other method, which is our third learning target for today, which is using Huron's formula. So like I said, these are our triangles that are SSS triangles, side, side, side. And the formula is A equals square root, a big square root, kind of like the one that we have in distance formula. Super long. And then we have S parentheses S minus A, close it, S minus B, close it, S minus C. Okay, so the A, B, and C we know represents the sides, but what does this S mean? This S is found by taking half of all of the sides being added together. So all sides getting added together, I believe that's perimeter, right? But the weird part about it is that 1/2. So the 1/2 makes it a semi-perimeter. That's what the S stands for. All right, let's see solving these area ones. So diagram goes out first. And we have A, B, and C. Angle B is 130. Side A is 92. Side C is 30. And it looks like I have an SAS, right? So we are going to use the first SAS ones, the orange equations. And it looks like I have angle B. So we're going to find area equals 1/2 the two sides, 30, 92, and then sine of the angle, 130. Plugging this into my calculator, 1/2, I want to double check, I have it good, 92, 30, sine of 130, and I got my area. Let's go hundredth again. So 1057.14 area, guys. I don't have units, so I'm going to represent it by units squared. And that's my final answer. Okay, let's try B. So B looks like, if I draw out my diagram, triangle, label my sides, A, B, and C. Plug in my knowns. Side A is 8, side B is 10, side C is 13. I don't have any angles, so I'm going to use Heron's formula. So first thing I like to do is solve for the semi-perimeter. So 13 plus 8 plus 10, and take half of that. We should be getting a 15.5. All right. Show me the work, please, of plugging into the actual Heron's formula. So starts with an S, so 15.5. Some of you guys maybe are already doing in your head the 15.5 minus 8. I'm totally cool with that. So that's a 7.5. And then 15.5 times 10, that's a 5.5. And then 15.5 minus 13 is a 2.5. Okay? Make sure you either show me that step or the step before of showing 15.5 minus 8, okay? You got to show me some type of work. Plugging all of that in, make sure it's underneath the square root. You should be getting a 39.98 units squared. Again, don't forget the units squared, guys. All right, so we were able to use both types of formulas, and now we're going to go into example 2. If law of sine produces two valid triangles, right, so we had an ambiguous case, would the areas of the triangles be different? You got two triangles, different triangles, then yeah, right? Absolutely. When you calculate the two areas for the two different triangles, they will not be the same. All right, so let's try one bearing problem in this part of the video. A hiker travels at 3.9 miles per hour. Okay, so that's like the speed. And they're heading southeast 21 as a bearing from a ranger station. After 3.5 hours, how far south and how far east is the hiker from the range station? Okay, so we have to figure out, they gave us the bearing. Okay, so right away I start off with my poles. Again, I like to draw out my pole, my north and my south a little bit bigger, so I understand I have to start my bearings, right, from the south or the north. So he went a 21 southeast. Okay, so southeast is going to be like this, right? And now a 21 will go in here because south to east, perfect, that matches. And his speed was what? How long? He was going 3.9 for 3.5 hours though. So I should be getting 3.9 times 3.5, 13.65. Okay, and it's miles. So I'm going to put that miles there. I'm totally cool, guys. If you just want to write this out, that's fine. Just showing you where it's coming from. And now they want to know how far south and how far east. So I want to know if he started here, how far south did he go and how far east did he go. So I'm going to label this Y, label this X. I have that 90 degrees in there. So from 21, because that's the only angle that we know, let's solve for X first. So I have X and I have the hypotenuse. So that is sine of 21 is opposite X over 13.65. Cross multiply here, so X multiply by 13.65 times sine of 21 degrees, 13.65 times sine of 21. I got X to be about 4.89 miles. And that's the east direction. So I got half of my answer. Make sure you put a box, something around it to show that is your final answer, okay? And now let's do the opposite one. So I'm going to use now the Y with the hypotenuse, and 21 is the only degrees still, so that's adjacent. So cosine of 21 adjacent over hypotenuse. Cross multiply for this one, so 13.65 times cosine of 21 times cosine of 21, and I get Y to be about 12.74 miles. Again, don't forget those units, and this was the south direction. All right, guys. Good job with part 1. Make sure you go into part 2 where we get more into these bearing problems.